Okay, so the lesson today is a little more difficult anyways than the first three in the chapter. I don't think most people think that the first three sections, which, by the way, we're going to have a quiz on next class, 3.1, 3.2, 3.3. Stop. So it's what the homework was last night, but it does not include this. This is the section where we actually solve equations, both exponential and logarithms. And it's usually a little more difficult. The last section, 3.5, is called exponential and logarithmic models. And so it's basically word problems where you end up having to solve equations. Okay. So the first way that we solve, and sometimes actually we end up using this property anyways. We actually already saw this 2 sections ago, and we solved it just by inspection, right? If the log base 2 of x equals the log base 2 of 3, what does x equal? It's 3. That's what they call a one-to-one property, right? If the logarithms are the same, it must be that the arguments are the same. So we're going to say x equals 3. That's what we mean by one-to-one. And we do that, in the course of solving things, simplifying things. I mean, that just comes up. The next one is not exactly one-to-one at this point, but if I rewrite the 32 as 2 to the 5th, which it is, now, it's an exponential on each side. They have the same base, so it must be that the exponents are equal. So what does x equal? 5. That's a one-to-one property. X equals 5. Right. The last one, especially if you have 2 logarithms like that you can add one to the other side so that it looks like that. Now you can use one-to-one property. So you do a little bit of rearranging, and then you say x equals 3. Must be the same. Right. That's something. You think there's 2 homework problems that do that mostly, but for the most part, what we're going to do is a little bit different than that, and that's what we get to in the next couple slides, or the